An easy way to check that two triangles are similar is by checking that their angles are congruent. On the one hand, please remember that when we have two parallel lines like KM right here and JN, if they are parallel, then they form with a transversal LJ these two angles that are called corresponding, and those two are congruent due to the fact that the lines are parallel. So that means that the triangle LKM and LJN have two angles that are congruent. So angle L and angle LKM are congruent to angle L and angle LJN respectively. So that means those two triangles LKM and LJN are similar. So due to that fact, we can establish a proportion between the sides of those two triangles. That's exactly what I just said. The two triangles are similar by the criteria angle of similarity. And because of that, we can say that LJ is to, sorry, LK is to LJ as LM is to LN. And if that is the case, of course, we can use the information given to find the measure of LM. We know that in this case, LN is 9.6. So if we replace that 9.6 right here and the remaining information, LK we know is 3, LJ we know is 5, was actually 8. 3 plus 5, that's 8. So we can cross multiply it here to find out what LM equals to. So we can, knowing that now that what that LM equals to, then of course we can see that we can also form the ratios LK to KJ. LK to KJ is 3 to 5, and this right here is, when we subtract, that'd be 6. So we have the other proportion LM to MN, which is the same. So our conclusion is that KM, uh, the segment that is parallel to one of the sides in the triangle, actually determines two sides here, LK and KJ, or segments that are proportional to the segments LM and MN. That is going to be an important result that we'll see next, leads to other uh, results that we will use in these lessons, in this particular lesson 7-5. So please try to use the same reasoning here and see if we know that BD in this case bisects each one of the sides AC and CE. We can tell because these are two congruent segments, 5 and 5, and it also bisects the other side, 6 and 6. So question is, can we go backwards and determine whether these two are parallel or not? And please give it 1 minute and then pause the video. And when you have an answer, please don't forget to check it. Yes, those two triangles, CAE and CBD, will be similar due to another criteria, which is side angle side, that determines triangle similar. Um, the two triangles, the two sides BC and CD are proportional to CA and CE, and the angle made by those two sides are the same, are congruent. So that's in this case angle C. So because of that criteria, which is another way to prove two triangles are similar, we can tell that those two lines, BD and AE, are parallel due to the fact these two angles are congruent. If corresponding angles are congruent, then those two lines must be parallel. Um, so let's have a look at example number 2, but before, like, we have this in a form of a theorem. So we can say that this is always the case. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. It's called by the side splitter theorem. So that's exactly what we did in example 1. We know that these two segments here, BM and MA, are going always to be proportional to BN and NC. And that is, of course, provided that the line or segment, line segment MN is parallel to um, one of the sides of the triangle. And in the triad, we came to the conclusion that these two triangles, if this happens to be like a segment that bisects the other two sides, the segment, line segment GH, is always going to be half of the third side, and that is because the two triangles are similar. So if the side ED is double the length of GE, of course, the side DF will have to be double the segment GH due to the fact those two triangles are similar, as we said before. It's called the triangle mid-segment theorem. So in example 2, we want to use this theorem to find the length of some sides in a triangle. So first, to find x, x involves only the segment SP and TR, so we are forgetting the line UV for a second. And knowing that this line is parallel, line segment ST is parallel to the side PR, we can establish a proportion such as PS is to SQ as RT is to TQ, the two segments on each side of the triangle. So when we replace the information in the diagram, PS equals x plus 2, SQ equals 16, RT is x, and TQ is 12. If we solve this equation, we find out that x equals 6. So knowing that x equals 6, of course, we know PS is going to be 6 plus 2 is 8. And if this is 4, that's 12. So now we have PU equals 12. And again here, this VR will be 3 plus 6, which is 9. And we can tell that V is the midpoint of QR, and U is the midpoint of PQ. So we can now use the midpoint theorem to find out what Y equals to. So please give it a try and pause the video when you feel you're ready, Then check your answer. Yes, y should be half of the length of PR. And of course, this will be 20. So the value of z will be 20. All right, so